Welcome back to Anatomy Lab. Today we're going to examine the appendicular skeleton of mammals as exemplified by the cat. So we're going to divide this, as in the chicken skeleton, into two parts. First, we examine the forelimbs in the pectoral girdle, and then the second part will be about the pelvic girdle and the hind limbs. Starting with the pectoral girdle. So in mammals, the most prominent and actually sometimes the only remaining bone in the pectoral girdle of mammals is the scapula, these shoulder blades, as it is sometimes called. Remember that in other tetrapods, for example, in other vertebrates, the pectoral girdle is composed of at least two bones, the scapula, and there's the coracoid or precoracoid. But in most mammals, there's only the scapula, the shoulder blade. The coracoid has been lost. More accurately, the coracoid actually was reduced into a tiny process called the coracoid process of the scapula. So that's the only remnant or relic of that previously prominent bone in the pectoral girdle. So the scapula, there are subparts to the mammalian scapula. This is the lateral surface, this is the medial surface. So if you position it relative to the eggshell skeleton of the cat, so this is the rib cage. So the scapula would be oriented like this, beside the rib cage, and with this spine laterally projecting. And this is the medial surface facing the spine, right? Something like that. And the scapula is not articulated to anywhere the eggshell skeleton. It's only supported by muscles. It's suspended by the so-called muscular sling. So it's actually floating in muscle, not directly connected to the spine, unlike the pelvic girdle. So what are the subparts of the scapula? You have the spine, this projection here on its lateral surface, spine of scapula. And there are three borders to the scapula, and you have to know this because you're going to use this when you study muscle origins and insertions. The forward-facing border or edge of the scapula, this concave edge, is called the anterior border because it's the one facing forward. At the back side, this more straight edge is called the posterior or axillary border. And the top border here is the vertebral border of the scapula. And in between the two, or on either side of the spine, the scapular spine, are spaces to be filled with muscles. The more anterior space is called the supraspinous fossa. The one behind is the infraspinous fossa. And if you move more distally from the spine of the scapula, you'll encounter two projections. The one pointing backwards is called the metachromion process. The metachromion process is actually more prominent in the shoulder blade of the rabbit. This is a rabbit scapula. A very prominent metachromion process. So back to the cat. Metachromion process. And then that downwardly projecting process is called the acromion process. If we look on the underside, the medial surface of the scapula, this space here to be filled with muscle again is called the subscapular fossa. Right. And also in the medial surface, you'll see that projection called the coracoid process. As I said, that it's the only remnant of the coracoid bone. Coracoid process. And then, just like the other pectoral girdles, there's the shoulder socket to which the humeral head will articulate. That's the glenoid fossa. Right, so let's head over to the limb. Forelimb. Upper arm bone, humerus, forearm bones, the radius and the ulna. And then this is the hand, composed of the carpals or wrist bones and the metacarpals or palm bones. Starting with the humerus, the part that is actually that fits into that socket, the glenoid fossa, is the head of the humerus. And just like in the chicken, there are also projections around or surrounding the head of the humerus. This one, which is more prominent, is the greater tuberosity. Greater tuberosity. And then that tinier bump there beside the head is called the lesser tuberosity. Okay, so greater, lesser tuberosity. Right, so moving distally, we'll find the condyles of the humerus, which will form the elbow joint. Beside the condyles are those smooth surfaces there, forming a hinge joint. Beside it is a rough protuberance there. Those are the epicondyles. So you can distinguish, you can be more specific. So this one would be the medial condyle, and this is the lateral condyle. Correspondingly, this is the medial epicondyle, and this is the lateral epicondyle. How do we know which one is medial, which one is lateral? That's your assignment, actually, how to distinguish the chirality, the handedness of long bones. So long bones have a right and left counterpart. How do you know if it's a right upper arm or left upper arm? It requires you to have knowledge of bony landmarks of the bone. Which one is always facing anterior, which one is behind, which one is dorsal, ventral. That requires you to have mastery of the anatomical landmarks of the bone. Right, but here's a hint. For the humerus, this hole here signifies the medial side. So this is the body, and this is the supracondyloid foramen, as it is called. So let's get the body, the actual skeleton of the cat. So in real life, the humerus would be oriented like this, right? Wherein the supracondyloid foramen is closer or more proximal, closer to the body. This is the medial side. And then therefore, this side of the humerus is the lateral side. So that's how I know that this is the medial condyle, and this is the lateral condyle. Medial epicondyle, lateral epicondyle. Just by looking at the supracondyloid foramen. But not all humeri. For example, the rabbit humerus doesn't have supracondyloid foramen. You have to rely on other anatomical landmarks, like for example, the greater tuberosity, which is more lateral than the lesser tuberosity. All right, so this notch here on the back side of the humerus, that's how you know this is the back side of the humerus. This is forward facing. This notch here is where the elbow process will be lodged. And as you know, the elbow has a fancy term, it's the olecranon process. So let's head over to the forearm. So this is the forearm. There are two bones to the forearm generally. That's the radius, and this one is the ulna. The ulna has an elbow projection there. That's the olecranon process. And in life, if it's still articulated to the upper arm, it's like this. Right? So I told you that notch behind the humerus is where the olecranon process is lodged. Give space for the olecranon process. So it must be behind. Right? So, ulna, olecranon process, and that notch there, which forms the elbow joint, is the semilunar notch. here's a disarticulated ulna. That notch there is the olecranon. That's the semilunar notch. This one labeled black is the olecranon process. And then that projection there, anterior to the semilunar notch, is the coronoid process. So together, the forearm bones and the humerus form the elbow joint. There, it fits like lock and key. Specifically, if you want to know which condyle of the humerus fits into this semilunar notch, it would be this one, the medial condyle. By the way, there's a fancy term for these condyles of the humerus in the cat. We borrow it from human anatomy. This is the trochlea. The medial condyle is called the trochlea, and the lateral counterpart is the capitulum. Trochlea, capitulum. So the one that actually fits into the semilunar notch of the ulna is this one, trochlea. So more distally of the radius and ulna would be the wrist bones, the carpals. And there are a bunch of carpal bones in mammals. Many of them have fancy names, anglicized names borrowed from human anatomy. So how do we go about this? Let's start with the carpal bone that is directly distal or immediately distal to the radius. So this large bone here, immediately distal to the radius, is the scapholunnar bone. Okay. And then move laterally, the one more immediately distal to the ulna is called the triquetral bone. Scapholunnar, triquetral. And then if you move more laterally, there's a sesamoid bone here, projecting. That's a pisiform bone. It's a sesamoid bone just like the patella, meaning it ossified from a tendon. Right? So those are the proximal series of carpal bones, the scapholunnar, the triquetral, and the pisiform. Then move more distally, just before you reach the metacarpals, is a row of carpalia, but in this case, can we distinguish it? So here's another hand skeleton of a cat to show you a better arrangement of the carpal bones, because in this specimen the distal carpals are obscured, right? But we distinguished the scapholunnar, the triquetral, and the pisiform, but the more distal carpals before the metacarpals are not distinct. So here's another hand specimen to orient you. This is the scapholunnar, this is the triquetral, and that's the pisiform. So these two are of different chirality. This one is the right hand, right manus. This one is a left hand. Right. So the distal carpals are the following, starting from the medial side, from the thumb. This is the thumb, the first digit. The closest carpal is the so-called greater multangular. Okay, that's a fancy term, anglicized name. Later I'll tell you the equivalent Latinized comparative anatomy synonyms of these. This is the lesser multangular. So starting from the digit 1, you have the greater and then the lesser multangular, and then move laterally. This is the capitate, and last one is hamate. So the one next to the digit, the first digit, the thumb, is called the greater multangular. One adjacent to the second digit is the lesser multangular. Adjacent to the third is capitate, and then adjacent to fourth and fifth digits is the hamate carpal bone. So together you have scapholunnar, triquetral, pisiform, projecting underneath, greater multangular, lesser multangular, capitate, and then lastly hamate. So back here, scapholunnar, triquetral, pisiform, and then the multangulars are obscured, but you can see the hamate bone, and then the hamate. This is capitate, hamate. Those are the carpal bones of the cat. So these carpal bones more or less are preserved or conserved in other mammals, but some carpal bones may fuse or may be separate in other. So for example, in the rabbit, the scapholunnar bone is separate into a scaphoid bone and a lunate bone. But we'll be studying the cat, so it's important to know the cat's carpal anatomy. So I'll be flashing on the screen the synonyms of these fancy anglicized names of the carpal bones. So in general, in mammals, we invent or we borrow fancy names from human anatomy, which makes it confusing and difficult to draw homologies with other vertebrates, in which we use a standardized Latin-based comparative anatomy terminology. So here's a table somewhere on your screen. I'll be flashing the equivalents of those, the synonyms of those anglicized names that I enumerated. So for example, the scapholunnar bone is actually equivalent or homologous to the radiale and intermedium. So it's a fusion of the two carpal bones, the radiale and the intermedium, whereas the triquetral bone is homologous to the ulnare. So notice how the Latin comparative anatomy synonyms are more logical, if you get what I mean, in terms of their nomenclature, because it's called ulnare because it's the one closest to the ulna, and it's called radiale because it's closest to the radius. But hey, mammals like us love to be special all the time, so we invent special names for our anatomies. So those are the carpal bones, and then obviously this distal bones to the carpals would be the metacarpals. There are 5 metacarpals in mammals. So 1, 2, 3, 4, 5 metacarpals, and those are the phalanges forming the fingers, and those are the claws, the tractable claws of the cat. And that would be it for the forelimb anatomy. Let's head over to hind limb and pelvic anatomy.